This video discusses Git branches. We will start with an overview of branches. All commits of a project belong to a branch. By default, commits belong to the master branch. A branch is a set of commits starting with the most recent commit in the branch and tracing back to the project's first commit. In this example, starting from the most recent commit on the branch, the master branch contains commits B and A. The feature X branch contains commits C, B, and A. Notice that commits B and A belong to both branches. Let's take a look at some of the benefits of branches. We will see that creating a branch is fast and easy. Creating a branch only creates one tiny file, a reference. Branches enable experimentation. Team members can isolate their work so that it doesn't impact others until the work is ready. Branches are not aware of other branches. This allows you to experiment with changes to the project, while at the same time the team retains a stable version of the project. If you have an idea for a change, you can create a branch and test your idea. Later, you can throw out your branch or merge it into the official project. Branches enable multiple team members to concurrently work on the project, without stepping on each other's work. Merging the work together later usually is not too difficult. Branches allow you to support multiple versions of the project simultaneously. For example, if the project is a software project with customers on several supported versions, you can update each version if an important hotfix is necessary. Branches can be short-lived or long-running. Short-lived branches are commonly called topic or feature branches and usually contain one small change to the project. For example, a topic branch may contain a new feature, a bug fix, a hotfix, a configuration change, or any other change that the project requires. When it's ready, a topic branch is merged into a long-running branch. In this example, the feature X branch is a topic branch. 2 commits were needed to create the feature, and then the feature was merged into the master branch. Long-running branches like the master branch live longer than topic branches and can even live for the life of the project. Examples of branches that might live for the life of a project are a master branch or a develop branch. We will see later that Git branches are flexible enough to work with many types of workflows, so you can pick a branching strategy that works best for your team and for your project. Branches are located in the local repository and in the remote repository. To view local branches in Sourcetree, click on the Branches tab. To view remote branches, click on the Remotes tab. Next, we will discuss creating a branch. Creating a branch simply creates a new branch label. Here we start with just a master branch containing 3 commits. We can create a feature X branch off of the most recent master commit by creating a feature X branch label pointing to the commit. To create the feature X branch label in Sourcetree, click on Branch to bring up the branch window. In the window that opens, select New Branch. Type the name of your branch and select Create Branch. We'll discuss the other options in the window a little later. Next, we will discuss checkout. Checkout is usually related to branches and does 2 main things. First, it switches the current commit, which is the commit that the head reference points to the checked out branch label or commit. In this example, if we were on the master branch and then checked out the feature X branch, the head reference changes from pointing to the master branch label to pointing to the feature X branch label. The second thing that checkout does is it updates the working tree with the files from the checked out commit. Once you have checked out a branch, you can work on and commit to the branch. In this example, the feature X label points to the same commit as the master branch label, so at this point the working tree files will be the same for both branches. Creating a branch will also check out the branch if the Checkout New Branch checkbox is selected. Checkout New Branch is selected by default. This means that after you create the branch, the working tree will be updated if necessary, and the next commit that you make will belong to the new branch. Here's a look at what happens if you create a branch without having the Checkout New Branch checkbox selected. After creating the branch, the head reference remains on the original branch. The only thing that you've done is create a tiny feature X reference. If you change the project at this point and make a commit, that commit would belong to the master branch because you have not checked out the feature X branch. In other words, if you don't check out the new branch, the head reference still points to the master branch label, and new commits will be made to the master branch, leaving the feature X label behind. If you create a branch and have the Checkout New Branch checkbox selected, the behavior is different. Checking out the feature X branch means that the head reference points to the feature X label, and if necessary, the working tree will be updated with the files from the commit that you checked out. This means that any work that you commit at this point will belong to the feature X branch and not the master branch. After you've created and checked out the feature X branch, as shown on the left, the next commit that is made will be made to the feature X branch. The head reference moves along with the feature X label, and the master label stays where it was. The master branch no longer points to the latest commit. In fact, the master branch doesn't know about the feature X branch label or about the latest commit on feature X. This is how the feature X branch can make changes to the project without disturbing the master branch. To change branches in Sourcetree, simply click on the branch that you'd like to change to. This performs a checkout, which means that your working tree will be updated with the files from that branch, and the head reference will change to point to the new branch label. Once you've switched branches, any work that you commit is to that branch. In this example, we have switched from the feature X branch to the master branch. Our working tree will now contain the latest files from the master branch. If you attempt to check out a branch but have unsaved work on the current branch, Git will notify you. In general, Git will notify you when it thinks you might lose unsaved work. In this example, we were on the feature X branch and made some changes to the working tree. Attempting to switch to the master branch brought up a confirmation dialog. If you click on OK at this point, your uncommitted changes will be saved by Sourcetree, and you are switched to the master branch. The working tree is updated with the files from that branch. When you switch back to the feature X branch, you will see your uncommitted changes. If you had checked the Discard Local Changes button before clicking OK, the local changes would be lost as you switch branches. Once we have checked out master, we can do some work in the working tree and create a commit. Now the feature X branch and master branch both have a commit that doesn't belong to the other branch. You can see that commit D uniquely belongs to the feature X branch, and commit E uniquely belongs to the master branch. Next, we will discuss detached heads. Usually you check out a branch, which checks out the commit that the branch label points to, but you also have the option of directly checking out a commit. For example, you might check out a commit to temporarily view an older version of the project. Checking out a commit rather than a branch leads to a detached head state. This means that instead of the head reference pointing to a branch label, head points directly to the SHA-1 of a commit. So a detached head basically means that the head reference is detached from a branch label. Git will warn you that if you continue, you will be in a detached head state. In this example, in the before state, we have the master branch checked out as is normal. If we then check out commit B, that commit will become the current commit, and the head reference will point directly at commit B, creating a detached head state. Here we are on the master branch and attempt to check out the initial commit by double-clicking on it. Sourcetree will warn you that your working tree will be updated with the files from that commit, but you will then be in a detached head state. Click OK to allow this, or cancel if you want to remain on the master branch. Temporarily viewing the files of a commit while in a detached head state is perfectly fine. However, if you want to work on files of the checked out commit and create new commits, you should create a branch on that commit first. On the left, we have checked out commit B, creating a detached head. If we want to create commits based off of commit B, we should first create a feature X branch label and check out that branch. That puts us back in the normal state where the head reference points to a branch label. The next commit would then be made to the feature X branch. Finally, we will discuss deleting a branch label. Deleting a branch really just means that you're deleting a branch label. Deleting a branch label normally does not delete any commits, at least not right away. In the example on the left, we created a feature X branch. This simply added the feature X label to the latest commit. If we then immediately delete the feature X branch, all that happens is that the feature X label is deleted. This shows how truly lightweight Git branches are. One way to delete a branch label in Sourcetree is to right-click on the branch that you want to delete and select Delete Branch. In this case, we want to delete the feature X branch. Click OK to delete the branch label. Git will check to see if you're putting committed work at risk by doing this. This can happen if you have commits on the branch that don't belong to any other branches. If you won't lose any work, the branch label will be deleted. If deleting the branch label puts some of your commits at risk, Git will not allow you to delete the branch label. If you know that you don't care about the unmerged commits, you can click the Force Delete checkbox before trying to delete the branch label, and the branch label will be deleted. Let's take a look at what could happen if you check the Force Delete checkbox when deleting a branch label. Let's say that you created a feature X branch off of commit C of the master branch, as shown. Then you did some work on feature X and made commit D. At that point, if you tried to delete the feature X branch label, there would be a problem because commit D does not belong to any other branch. Sourcetree and Git normally will not allow you to do that. However, if you select the Force Delete checkbox, that means that the feature X label will be deleted and you're left with what's called a dangling commit. Commit D doesn't belong to any branch. Git will periodically garbage collect, looking for and deleting old dangling commits. So be careful if you check the Force Delete checkbox. It assumes that you want to throw away the work that is in the dangling commits. Here is a review of what we've discussed in this video. A branch is a set of commits that trace back to the project's first commit. Creating a branch creates a branch label. Checkout involves updating the head reference and updating the working tree. A detached head reference points directly to a commit. Fix a detached head by creating a branch. Deleting a branch deletes a branch label. Dangling commits will eventually be garbage collected. Now it's time for you to try the things discussed in this video. Separate hands-on instructions are provided.